Well, I will get started, and if anybody else joins, I will admit them in. Everybody see my screen all right?
Yes, sir, I can see it.
All right, perfect. Okay. So today I'm going to be talking about structural monitoring using Leica GeoMoS. But before I start, I'm just going to talk a little bit about myself. My name is Ben Rantala. I'm currently NSS Canada's Technical Support Specialist. I graduated from Cambrian College about 3 years ago now. 2 weeks out of school, I got hired by NSS Canada and been here ever since. So right now, NSS Canada's key GeoMoS clients are scattered throughout Ontario. We've got Ballet, Glencore, Newmont, Goldcorp, Rio Tinto, Detour Gold, as well as some other ones. So today, what I'm going to be talking about is introduction to monitoring, the Leica GeoMoS monitoring solution, required software, instruments, and equipment to go along with the GeoMoS monitor. We have the Leica GeoMoS analyzer and installation and setup, and finally, any questions. So we have monitoring in our everyday life. We have public monitoring, health monitoring, baby monitoring. In London, England, there's an estimated 500,000 surveillance cameras watching the streets and sidewalks, with a total estimated of 4,200,000 surveillance cameras in the UK alone. That's one camera for every 14 people. We use everyday health monitoring using smartwatches that we have built in with heart risk monitoring, sleep tracking, and daily step counter. And we also have baby monitors. Monitoring is used in our daily lives, whether we know it or not, but when it comes to monitoring in the surveying world, it's a totally different ballgame. So what is monitoring in the surveying world? Monitoring, also referred to as a deformation survey, is the systematic measurement and tracking of the alteration in the shape or dimension of an object as a result of stress induced by applied loads. What is the purpose of monitoring? Deformation monitoring is a major component of recording measured values that may be used for further computation, deformation analysis, predictivity maintenance, and alarming. Leica GeoMoS monitor's main goal is to identify, analyze, and anticipate risks that could pose a threat to the project at hand or the people working within the project. The Leica GeoMoS solution. Leica GeoMoS is for the monitoring professionals who need to understand and react to complex demands and safeties of current and upcoming monitoring projects. Leica GeoMoS Monitor is a complex yet straightforward automatic deformation monitoring software that can adapt and match the needs of any monitoring project. It is a multi-purpose unit that can monitor construction sites, roads, dams, tunnels, bridges, high-rises, historical buildings, foundations, mines, landslides, and volcano slopes, settlement areas, and earthquake areas. How Leica GeoMoS works. Leica GeoMoS Monitor is a central unit for data acquisition, which processes and alerts such applications as structure movement, climate change, building construction, natural resources, or energy managing monitoring. The data collected can then be used in Leica GeoMoS Analyzer to graphically and numerically visualize the results with customizable reports with filter and search options. How Leica GeoMoS Monitor acquires this data? So first, what we have is the main components. So we have the software, the instruments, and the equipment. We have the CLM, which we download on a computer, which does all our licensing. We have the software, which everything talks to, so all the equipment talks to. We have the CommGate that talks from the instrument to the monitor software. We also have the monitoring station sensors and prisms, such as GPSs, piezometers, so on and so forth. We have the monitoring station building with electrical and Leica GeoMoS Analyzer software and GeoMoS Now software. I'm going to explain, get further into detail as we go on. So the Leica CLM floating or node lock license server. So depending on what you want to do, we have two license options. So we have the node lock license or the floating license. Node lock license are fixed to the computer where the software is installed. So for instance, you have it on a desktop installed in the main ground control room. That is where everything's going to go through. Floating licenses are installed and shared within the single network. So different users working on different computers within that network can use this following licenses. So we could have GeoMos monitor installed on a couple different computers in the office. While somebody's away, you could be working on one reporting and another guy could be working on another report, so on and so forth. Then we have the Leica GeoMos monitor software itself. So with a variety of software options, we have the Leica GeoMos adapts to specific needs of any user's monitoring situation, making it suitable for continuous or periodic projects supported on desktops, laptops, and virtual machines. Leica GeoMos monitors offers functionality, including the options for messaging and limits, computations, API, and export to adjustments. These software options can be purchased at the time of the monitoring software or after if you feel like one would be a key asset to the working project. So if you feel like messaging and alerts is something that you don't need right away, then you could get the license for it in the future. The Leica GeoMos software is highly customizable, allowing you to purchase only the functionality you require. Creating new projects in the software itself. Easily create new working projects with different user levels. Customize the units, the panes, the fonts, the animations, and even background image of the working project or key areas of monitoring. So you can change your meters, displacement values, decimals. You could.
Ben?
Yes.
Sorry to. There's a bunch of people that are trying to get in.
Okay.
Can you let them in?
Yeah, that was just Marty. Okay.
Okay. Perfect.
Okay. Thank you. Sorry. Back here. Yeah, so easily create new projects. You could have multiple projects in there, and you could have multiple projects running at the same time, which is an awesome feature. So coordinate systems, easily add a coordinate system to the working project with either the preloaded coordinate systems or user site-specific created coordinate systems. I know a lot of mines that I go to use their own mine site coordinate system, so I could input that right into here. If the coordinate system is not used, it should be configured. If the coordinate system is to be used, it should be configured before any points are learned and is required by the GPS sensor. So basically, before doing any of monitoring, we want to establish a coordinate system. Then we go into the Leica GeoMos monitoring measurement cycles and customizable options. So Leica GeoMos monitors uses sophisticated, simple, and versatile measurement cycles, scheduling customizable to the user. Create single or multiple scheduled measurement cycles. Assign limit checks to individual measurements. Assign an alert action or messages for deformation, system health, communication, and quality issues and errors. So if the comm box isn't working right, you're going to get a pop-up error saying communication with the comm box, error in communication. View and analyze data locally or in the cloud using a range of graphs, images, maps, and tables. Point editor. So use the import coordinate file button or import GSI files to import a list of points from a formatted ASCII file. You could insert manual points in the point editor. Give them coordinates using learn in the point editor. So basically, there's a learning function. I'm going to explain further when we install the Prism, but basically what you do is point the total station toward the Prism you want to learn. You press learn. Oh, sorry. You press learn. And what it does is it'll actually give you the coordinates of that. And if you want to save it, you're satisfied with that, you just hit save. Here's the CommGate. So the Leica CommGate 10 router or industrial device servers. So a wide range of communication technologies are supported for sensor control and data acquisition, including cable, bus systems, radio, LAN, WLAN, GSM, GPRS, UMTS, and WiMAX. Leica CommGate 10 and the 20 routers can either be configured with a direct Ethernet connection or mobile connection. via an internet provider, SIM card, such as Bell, Rogers, Telus, etc. Can also connect an industrial device server, such as the Industrial Lantronix Express Device Server, which basically is a CommGate box, different brand. And it is configurable serial interface and direct ether connection as well. Then we have our Leica GeoMoS monitoring stations. Leica GeoMoS monitoring CommGate routers or device servers can easily communicate with a variety of Leica instruments. We have the TPS 1000s, the TPS 1100s, the TPS 1200s, TM30s, TS15s, TM50s, TS16s, TS60s, MS60s. So up here we have the TM50s, and down here we have the MS60. The only difference between the two is the scanning capability of this guy. Leica monitoring stations can withstand the roughest use in the most severe environments, operate throughout a wide temperature range, and fully function in bright sunlight or complete darkness. So here's some Leica GeoMoS monitoring sensors that we could add to a GeoMoS monitor. So Leica GeoMoS monitor can utilize a variety of sensors to ensure reliable data acquisition in the roughest weather, temperature, and pressure conditions. We have the meteorological sensor, which measures climate and weather change, adjusting the monitoring station settings for its surrounding environment. We have the piezometer sensors, which monitors the pressure depth of groundwater that helps Leica GeoMoS monitor distinguish false ground movements. Leica GNS antennas, GPSs, can provide added real-time analysis capabilities and improve status information with multiple sensors monitoring stations.
Hey, Ben?
Yeah.
Can you check if people want to come in?
Just did. Thank you. And then we have our Leica GeoMoS monitoring prisms. Leica GeoMoS monitor utilizes Leica monitoring prisms to achieve the most accurate and reliable data. Leica geosystems have a specialized anti-fog coating on the reflective surface and a copper coating on the reverse side. Without these, the range of distance measuring, automatic target recognition, ATR, and power search would be reduced by up to 30%. Leica offers a variety of monitoring prisms that can be utilized by GeoMoS that range from standard monitoring prisms to professional monitoring prisms. And depending on the job at hand, we'll determine what prism to choose. So we have this guy right here, which is our GMP 112. It has a range of 1,500 meters. Then we have our smaller prisms, which have a range of 1,000 meters, and they are my GMP 104s. Then we have our Leica GeoMoS analyzer software. So this is where all the data is pushed into. So this is where we're going to create sitemaps. We're going to look at displacements, velocities, vectors, multiple graphing options. Leica GeoMoS analyzers can display graphically and numerically all measurements and results. Combine the data for multiple points or sensors in a single graph to check for correlations or multiple graphs. The sitemap shows at a glance the status of your monitoring project. You can import photographs or maps to be overlaid with traffic light symbols displaying the limits. A variety of graphing options that can be shown as raw data, smooth data, or both. Leica GeoMoS Analyzer software continued. So Leica GeoMoS Analyzer can also import and export data and is used for data editing and post-processing for reporting purposes. Create graphs and report to show displacement, temperature changes, pressure changes, and other information and data acquired by monitoring sensors. Compare previous to newly acquired data, either by hourly, daily, weekly, monthly, or yearly to see and observe trends or jumps in data as seasons change or if the structure is actually moving. Leica GeoMoS does need some time to gather accurate and true displacement and deformation. This is due to many reasons. Adjusting to the actual movement of the structure, such as a building swaying, even slight wall movements in the open pits and so on. So by the time, I'd say by the time full install, getting reporting numbers, we're looking at about a month for true displacement numbers. So as you can see up, it's in the next slide, I believe you're going to see a little bit better. down here, you'll actually see these are all the same point IDs. And here it is, the displacement. So we have our horizontal, vertical, and our, so you can see it's slightly moving and adjusting. And that's where we see it up here in our displacement. So this is where we're gonna report everything out. So this is our DXF output files. So this is where we can send it to our ground control crews. This is where we're going to look at certain points, certain trends to see if, hey, we actually see something moving, or no, it's just, you know, we're going into spring, everything's thawing, things are going to be moving, so on and so forth. So now I'm going to get into the construction of the monitoring building. So this guy is a basic construction, not so basic. They want the structure not to move. So the following monitoring station building design has been constructed for stability, durability, and to acquire the most accurate data possible for Leica GeoMoS monitor purpose. This is just a recommendation and it does not have to be designed exactly as drawn. This was designed by Leica. This structure has been installed at one of our sites almost exactly like this. And it's been monitoring for about 6 years now and it hasn't moved. So ideal monitoring station building locations, as you can see up here, we have different monitoring stations. So I'm more familiar with the open pit monitoring. I've seen monitoring building stations almost hanging over the edge. I've seen them back here. As you can see, for the construction crews, they don't want them moving either, but there is something called free station. So if, for instance, you have to install your total station on something that is moving, what free station does is before it actually monitors, it's going to orientate itself first by shooting different prisms. And what it's going to do is it's going to, hey, I changed from this position yesterday to this new position. Are you okay with that? Yes. Boom. That's going to monitor and it's going to show you the displacements. So the monitoring station building should be built close enough to the edge of an open pit walls, but still at a safe distance away. The monitoring station building should have a clear view of the working project area with as little obstacles in the field of view as possible. There is no determined distance for the monitoring building installation and can be determined by the working project at hand. So if you're monitoring an open pit, you want to be as close to the pit walls as you can, but at the same time, you don't want the building to fall into the pit. For monitoring construction sites, you want it out of the way of large machinery working. You want it up high so that nobody could come along and adjust settings or change instrument heights, etc. I know I've been in the field working and all of a sudden I'm like, hey, how come my GPS just stopped working all of a sudden? And I go back and somebody took down my GPS. I'm like, oh, okay. So ideal reference monitoring prism installation locations. So what we're going to do is, in order for the total station to know where it is, we need at least 3 reference prisms. So like a GeoMos monitor station needs a minimum of 3 reference prisms to establish orientation before each measurement cycle. The Leica reference prisms are to be GPS surveyed in using their respected working project UTM coordinates or mine site established coordinate system. So the main idea for these guys here, as you can see, these are the reference prism installed on cement pads. They know they're not moving. So what they're doing is they're actually going in and surveying this point right here and adjusting it to the center of the prism and getting that center of the prism. They're getting 3 of those. So I need northing, easting, and elevation. That way, when I'm monitoring, the total station could reference itself off these prisms that have not moved. So you want them outside of the working project, which I'm going to go into next. So, like GeoMos monitoring stations. Yes. So ground state, like a reference needs to be installed within the working project, but out of the way of active working zones and ground stability issues. So these guys are out of the way, off to the side of open pit. In construction world, they would be probably just a little column off to the side of the building, or you could even attach it to the building, the bottom of the building. So the ideal Leica monitoring prism installation location. So now it's going into the monitoring prism. So the first ones that I just talked about were the reference prisms. These are the monitoring prisms. So the Leica GeoMoS monitor requires the monitoring prisms to be installed within the monitoring project, not on the outs like the reference prisms. The Leica monitoring prisms should be installed in areas of key operations, ground stability issues, highly active working areas, or areas that can pose a risk or a threat to individuals and or equipment. The Leica monitoring prisms do not have to be GPS surveyed in. These prisms are located using the Leica GeoMoS monitor software. So these prisms are not GPS in. They are actually shot in after we do our reference. We do our orientation with the gun. You go in and remember I was talking about the learn. We press the learn, we learn where this is. Bam. And that's it. Any questions? Oh. All right, open for questions. Sorry, guys, I couldn't figure out what to do there.
Really good presentation there, Ben. I personally don't have any questions, but that was some great information there regarding GeoMos.
Thank you. If anybody wants to take my contact information down or send me an email, I also, I don't just do GeoMos, I am the technical support specialist for NSS Canada. Any questions on just about anything, feel free to give me a call. If I can help you, I will dig into it. I have great references here working with me. So we could definitely answer any questions, concerns. If you need troubleshootings on any of your current equipment, anything like that, feel free to give me a call.
Hey, Ben, wanted to, every Wednesday, are we going to be hosting these types of webinars?
Yes.
Give everybody some information on that.
Yeah, every Wednesdays we are going to be hosting webinars. It's going to be different topics each week. I believe next week, if I'm not mistaken, are we total stations next week? Something like that. Total stations next Wednesday. I'm going to be doing some actual like Captivate software training and walkthroughs. Going to put together maybe some traverse reporting and stuff like that. If anybody in the presentation too would like me something specific to make a webinar on, by all means. If there's something you're having trouble with and you want me to make a document, by all means, feel free.
Do you have online training available? Like if we wanted to remote in with somebody and do some training?
Yes, actually, I did yesterday. I had a customer calling me. I needed some tech support, and I couldn't understand exactly what he was trying to do. So I actually got him to remote in onto my computer, and I went through the simulator. And once I did that, it actually broke down. So I knew exactly what he needed. I told him exactly what to do, and he's a happy camper. So yeah, by all means, if you want to email me, we could set up a webinar. We could do face-to-face chat. I know in these times right now, I would love to come to site, but I can't. So we could do some face-to-face training. Any questions that you have on just about any of the equipment that Leica offers, or even any of the equipment that you're using now, by all means, I'll research into it. I might have even played with it. So yeah.
Just to add one more thing to everybody. I saw a few people just join in last minute. If you did miss part of the presentation, we are recording the presentation. So if you miss part of it, you'll be able to download it and look at the whole presentation again, and the other previous week's presentations as well.
Okay, thanks. I am taking the account.
Thanks, everybody.
That's great, Ben. Thanks.
No problem. Thank you.
Thanks, Ben.